Hello everyone, my name is Gerard Massons. I'm working as an R&D engineer for DuPont Water Solutions. We are located in the Vila Seca wastewater treatment plant in Tarragona, Spain, where we have our OxyFilm pilot unit. Today I'm gonna guide you through the main characteristics and details of the piloting we are performing here. The OxyFilm unit is fed using primary clarifier effluent. Our feed flow is ranging from 70 to 290 meter cubic per day. And the main characteristics of the wastewater is a COD concentration ranging from 200 to 700 ppm. A soluble COD fraction around 200 ppm in average. Ammonia concentration of 50 to 25 ppm of ammonia nitrogen, and a TSS concentrations which can go up to 350 ppm. The primary effluent is then being pre-filtrated with a 3 mm size mesh to prevent that any large particles might arrive to the MABR modules. After that, the wastewater is then fed to the 12 meter cubic feed tank, where we have installed two OxyFilm modules, each containing 2,200 square meters of PDMS fibers. The two modules are operated in series, and the effluent is collected in the side tank, where we are analyzing for COD, ammonia, and nitrates concentration. The modules are scoured regularly to maintain an optimum biofilm thickness. An airflow of 230 meter cubic hour is used for an intense scour of the system. The duration and frequency are determined based on SDP results. After scouring is being finished, biofilm removed settles and is dislodged out of the system. After scouring is being completed, sludge settles and is removed from the tank using this piping system and a dislodge pump that helps to remove the settled sludge and transfer it to this IBC that is being used for measuring the volume and concentration of sludge produced. We are regularly lifting to weight the modules and confirm the amount of biofilm present by a load cell that we have installed in the pilot plant. The two gas cylinders you can see are argon cylinders that we are using to perform the biofilm thickness measurements that helps us optimizing the scour duration and frequency. Inside the container, we have all the instrumentation and PLC control of the unit. There's two membrane blowers, one for each module, feeding 10 meter cubic of air, and in the middle there's the dedicated mixing blower to be used as an airlift source in case the off gas is not used. Each blower is then going through a 5mm filter. We are measuring the flow and pressure for each module. Then it's going to the module, and the off gas is then measured the flow, and also we have oxygen and CO2 analyzers that are used in order to measure the oxygen transfer rate for each module. These two are the auto samplers. We have one for the feed and one for the effluent. The auto samplers are programmed in a way that we can quantify with the graph samples the average performance of the unit, and the samples being taken are stored in a fridge upon analysis. We also have on-light probes to measure ammonia in the feed and in the effluent. Currently, we have 52.6 ppm of ammonia in the feed and 0.4 ppm of ammonia in the effluent. The scar blower is controlled by the PLC that determines the scar duration and frequency and triggers it depending on the actual biofilm thickness. In the PLC, the technician can determine the set point for biofilm thickness, and results of argon tests are analyzed to determine the needed scoring conditions at any time. Now we're going to see the modules in operation. We are feeding 10 metacubic hour currently. That is feeding first in the module on the left, and then go through the second module on the right. Connections are placed here. As a process inlet and process outlet air, and feed water is fed through the pipe on the left. You can see the air lift on both sides that are feeding water from outside in, causing the flow of the first module to be top bottom. The second module is actually having a reversed air lift, pumping up the water and causing a drag force with a bottom top water flow. You can see the water which is running clear. You can see the cassettes of the module and the effluent water is collected on the right side in the tank. Where you could see that it's running clear, and where we have placed the ammonia sensor to analyze the ammonia concentration that is leaving the plant.